All right, buckle up for a deep dive that's going to really get those philosophical gears turning. We're taking on Mereology today, the study of parts and wholes.
Sounds simple enough.
It does, but trust me, this is philosophy we're talking about, so things are going to get, well, interesting to say the least. We're going off the Stanford Encyclopedia of Philosophy's entry on Mereology, and let me tell you, it's a dense one.
Oh, absolutely.
So think of this deep dive as your express lane to all the juicy bits, all the key ideas and debates in the field.
Yeah, Mereology, it might seem like child's play at first, but it takes you right to the heart of some seriously big questions, like what even exists, what makes a thing, how's all of reality structured,
Yeah.
the light stuff.
The easy questions.
Right.
So let's start with the basics. Mereology talks about parts, but how is that different from how we use the word part normally?
Well, in everyday talk, part is all over the place. Parts of a machine, parts of a speech, parts of a city, you name it. But Mereology is way more focused. It's all about the specific connection between a part and its whole, not just any old association.
Okay, so like the engine is part of the car. That's Mereology territory.
Yeah.
But the wheel is part of a car's mechanism.
Yeah.
That's not necessarily Mereology.
Exactly. Mereology is all about how things are put together, literally. It's not about what they do or what they're made of or their purpose, just pure structure.
So it doesn't care about what a thing's made of. Like the clay is part of the statue. That's not a mereological claim.
Bingo. That's talking about what the statue's made of, not the relationship between the clay and the statue as two separate things. Mereology only cares about a thing and its proper parts, the pieces that make it up, but aren't the whole thing itself.
Right, so we're talking about the pieces that literally fit together to make a thing, not the stuff it's made of or its role in a bigger system.
Exactly. And here's where things get really interesting for philosophers. Mereology isn't just about physical stuff. It goes for events, abstract ideas, anything you can think of. A battle can be part of a war. A premise can be part of an argument. Even a property can be part of a concept.
So the same logic that applies to, say, a brick being part of a wall could also apply to a thought being part of an idea. That's pretty wild.
It is, and it really shows how powerful Mereology is for analyzing stuff philosophically. It's a way to understand how things are structured and how they relate, no matter what they actually are.
All right, so we got the basic parthood idea down. What are some of the big principles or assumptions that Mereologists use?
One of the biggest, and one that causes a lot of debate, is anti-symmetry.
Anti-symmetry. Rings a bell. Isn't that from logic and set theory?
It is, and it comes up in Mereology too. Basically, it says if A is part of B and B is part of A, then A and B are the same thing. They're identical.
That makes sense intuitively. Like, my hand is part of my arm, and my arm is part of my hand, so they can't really be separate things, right?
That's the simple version, yeah. But, like a lot of things in philosophy, there are some curveballs that make us question this seemingly obvious principle.
I love a good philosophical curveball. Hit me with an example.
All right, the classic one. A statue and the lump of clay it's made from. Some philosophers say the statue and the clay are parts of each other.
But they're obviously different things. The statue has a shape, the clay is just, well, clay.
Exactly. And that's the problem for anti-symmetry. If they're both part of each other but are clearly different, anti-symmetry kind of breaks down.
So do we just check anti-symmetry out the window then?
Not so fast. Mereologists have a few ways to deal with these weird cases. Some say anti-symmetry always holds true and try to explain these examples away, saying they don't involve actual parthood. Others say we got to tweak the idea of anti-symmetry to make room for these tricky situations.
So there's still a lot of back and forth on how to handle these apparent anti-symmetry violations. What other principles get Mereologists fired up?
Another big one is extensionality. The idea is that if two things have the exact same parts, they're the same thing.
That seems pretty intuitive, too. Like if I build two identical Lego castles, even though they're technically different builds, they're basically the same because they're made of the same Lego bricks.
That's the gist of it, yeah. But again, there are examples that throw a wrench in the works. Think about two words with the same letters, like team and mate. Same parts, different words.
So the arrangement of the parts matters, even if the parts themselves are identical.
Right, and then there's the classic ship of Theseus problem. If you swap out all the planks of a ship over time, is it still the same ship?
Ah, that's a classic. And what about a living thing versus a pile of its tissue? Same parts. One's alive, one isn't.
Exactly. All these cases seem to challenge extensionality.
So how do the folks who are all about extensionality respond to these challenges? Do they try to explain them away, like with anti-symmetry?
Some do. They might say those examples aren't really about having the same parts. Like, Maybe the ship of Theseus slowly becomes a different ship as the parts change, or the order of letters in team and mate makes them different. Others say we got to consider time or other factors when talking about parthood.
So just like with antisymmetry, extensionality leads to some pretty heated philosophical debates. Seems like even the most basic Mereology ideas are far from settled.
That's right. Mereology forces us to really think about how the world is put together and pushes us to come up with clearer, more sophisticated ways to understand it.
Okay, we've talked about breaking things down into parts. What about putting them together? How do those parts become wholes in the first place?
Now that's where things get even more interesting. That's the realm of composition principles.
Composition principles, like a Mereology rulebook for building a universe.
Kind of, yeah. Philosophers have been trying to figure out exactly when a bunch of parts actually make a whole and what kind of whole they make.
It's like that old riddle. How many grains of sand make a heap? At some point, a bunch of parts just becomes a thing, but where's the line?
You got it. And finding that line, the set of rules that define it, has been, shall we say, challenging. You want principles that explain the wholes we all kind of recognize, but not so broad that they create a universe full of nonsensical objects.
So what are some of the approaches to these composition principles?
Yeah.
What are the rules of the Mereology game, so to speak?
Well, one approach is looking for upper bounds. It means any two things, if they're connected in the right way, have to have something that contains both of them as parts. Think of it like if you got two Lego bricks, there must be some bigger structure that could hold them both.
Okay, I get that. But what does connected in the right way even mean? Do the bricks got to be touching, or can they be miles apart?
That depends on the specific composition principle you're using. Some say just overlapping is enough. If two things share a part, they got to have an upper bound. Others say they need to be physically connected or relate to each other in some way.
So there are different levels of strictness for these principles. Some are more free-flowing, letting lots of things be wholes, while others are more picky.
Exactly. And then there's the question of what kind of whole gets made by a bunch of parts. Is it just the sum of its parts, or is it something more?
I think we're about to go even deeper down the Mereology rabbit hole, but maybe that's for another time. For now, I think we've given our listener a good intro to the basic ideas and challenges of Mereology.
I think so too. And we've only scratched the surface of this fascinating field. And those different kinds of wholes, well, that's where Mereology really starts to get philosophically juicy.
Okay, so how do these composition principles change how we understand what even exists? It's not like picking a different principle magically makes new stuff appear in the world, right?
Not in a literal physical sense, no. But in terms of like our ontological commitments, the principles we choose can really affect what we see as a real object of study, something that exists in a philosophical sense.
So different composition principles lead to different ontologies, different theories about what exists. That's kind of a big deal.
It is, it is. Take, for example, a super permissive principle, one that says any collection of parts, whatever they are, forms a whole. That leads to unrestricted composition, where basically anything goes.
Wait, so I could just point at, like, my left shoe, a cloud, and a squirrel, and say, boom, new object. And I wouldn't be wrong.
If we're talking unrestricted composition, yeah, that would be a legit object, at least theoretically. You'd have a universe overflowing with these random collections, wholes that don't seem to have any real meaning or coherence.
It sounds like a hoarder's dream, but also kind of a philosophical nightmare.
Right, it gets out of hand quickly. Most philosophers think that kind of ontology, that idea of what exists, is way too bloated and unwieldy. It's philosophically extravagant, to put it mildly.
So what's the alternative? Do we go to the opposite extreme and say almost nothing can be a composite object?
Well, there are some middle ground approaches, of course. Many philosophers like restricted composition principles, where only certain groups of parts can make real wholes, but that just kicks the can down the road a bit.
Because then we got to figure out what makes a group of parts worthy of wholeness,
Yeah.
right? What's the criteria for being a real thing?
Exactly. There are all sorts of ideas out there. Some philosophers say the parts have to be connected in space in a specific way, or they got to be causally related, influencing each other. Others say they got to work together as a functional unit, have some purpose.
It's like we're trying to find the Goldilocks zone of composition principles. Not too empty, not too full, just the right amount of stuff in the universe.
That's a great way to put it. And this whole search for the right composition principles is tied to another big question: the relationship between a whole and its parts. Are they the same thing? Or is the whole something more than just the sum of its parts?
Ah, so we're back to that idea of identity we touched on earlier. Does this connect to the principle of extensionality?
It absolutely does. If we say a whole is, like, identical to its parts, then extensionality makes perfect sense. After all, if two things are made of the exact same parts and those parts are the things themselves, then how could they be different?
Okay, I see the logic there. But something about it feels off. It's like saying a car is nothing more than a pile of metal and rubber bits. There's clearly a difference between a working car and its parts all over the place.
That's a classic objection to the composition as identity idea, and it's a strong one. How can a whole have features that none of its parts have if it's nothing more than those parts? Like, how can a car drive or a clock tell time if they're just their parts arranged a certain way?
So what do the composition as identity folks say to that? Do they just shrug and say, yeah, cars can't actually drive, it's all an illusion?
Some might go that way, but there are more subtle answers too. Some argue that wholes have emergent properties, features that pop up from how the parts interact, even though those features aren't in the parts themselves.
So the arrangement of the parts, how they're organized and work together, that's what gives the whole its unique properties. It's not just the parts on their own, but how they come together.
Exactly. And this leads to some really cool discussions about emergence, causality, and how different levels of description work. We might say a car drives on a big picture level, but on a tiny level, it's just atoms and molecules doing their thing according to physics.
It seems like this view avoids that overcrowded universe problem from unrestricted composition, right? You don't get all these bizarre random objects just because their parts happen to be near each other.
Yeah, that's one of the nice things about the composition as identity idea. It gives us a more streamlined ontology, a way to explain wholes without adding a ton of extra stuff to the universe. But as we've seen, it's got its own issues.
This is all making my head spin, but in a good way. It really shows how Mereology isn't just some abstract puzzle. It really affects how we understand the world and everything in it.
Couldn't agree more. And speaking of challenging our understanding of the world, there's also the issue of vagueness and indeterminacy when it comes to parts and wholes.
Ah, yes, the real world, where things are messy and don't always fit neatly into boxes. It's easy to talk about Legos and car parts, but what about clouds, mountains, or even living things? They don't have such clear boundaries.
You got it. Think about a cloud. Where does it start? Where does it end? Is that little wisp of vapor at the edge still part of the cloud, or is it something else?
Or like a mountain range. Are those foothills part of the mountain or separate things? Even with the tree, is a leaf that's about to fall off still part of the tree?
These are all cases where parthood gets fuzzy, where it's not so obvious if something is or isn't part of something else.
So how do we square this real-world fuzziness with the neat, logical principles of Mereology? Do we just throw up our hands and say Mereology only works in perfect scenarios?
Not necessarily. One way to tackle this is to separate two kinds of vagueness, didicto and duress.
Okay, I've heard those terms before, but I always mix them up. Can you remind me what they mean in this context?
Of course, didicto vagueness is vagueness in our language or concepts. So a sentence like, that wisp of vapor is part of the cloud, might be vague not because the world itself is vague, but because our word part isn't super precise.
So it's like our language is too clumsy to describe reality perfectly. The world might be perfectly defined, but our words can't quite capture it.
That's the basic idea. In this case, each water molecule is either definitely part of the cloud or not, but our language doesn't have a clear way to say that.
And derive vagueness, that's the one where things get really weird, right?
You could say that. Derive vagueness means there's actual indeterminacy in the world. Objects can have blurry boundaries where there's no real answer to whether something is or isn't a part of them.
So it's not just our language that's vague, it's reality itself. That's a pretty wild idea.
It is, and it creates some interesting problems for Mereology. If objects don't have clear boundaries, then how do we use principles like extensionality? If two things share a blurry boundary, can we even be sure if they have the same parts?
It seems like derive vagueness throws a wrench into the whole Mereology machine.
It definitely makes things more complex. Some philosophers say it means we got to rethink some of our basic ideas about objects and parthood. Others try to come up with new versions of Mereology that can handle vagueness, or they argue that vagueness is just a problem with how we know things, not a problem with the world itself.
So even something as basic as parthood can take us deep into philosophical territory, raising questions about language, what exists, and even the nature of reality.
That's what's so great about Mereology and philosophy in general. It takes simple-sounding ideas and shows how deep and complex they really are, making us question our assumptions about the world and our place in it.
So it seems like Mereology keeps leading us to these big questions about what's real and how we know it. And speaking of big questions, there's another huge one in Mereology, the question of atoms.
Oh, yeah, the classic debate, atoms versus gunk. Is everything ultimately made of these tiny indivisible particles, or can we just keep dividing things forever?
Right, atoms. That's the idea that everything's built from these tiny unbreakable pieces like the ancient Greeks thought.
Exactly, Democritus, Leucippus, those guys. They pictured a world made from these tiny, solid, unchanging bits of matter. And it's a pretty attractive idea. It suggests a sort of order and simplicity at the most fundamental level of reality.
It makes sense. If everything's made of these basic building blocks, figuring out those blocks would be the key to understanding everything else. But what about gunk?
Yeah.
What would a gunky world even look like?
Imagine a universe where no matter how small you cut something, you could always cut it smaller. There's no end to the dividing, no ultimate bottom level. It's kind of mind-boggling, but it's a serious contender in philosophy.
It's like zooming in on a fractal, those endlessly repeating patterns. You never reach the end, just more and more detail.
A perfect analogy. And it raises some really interesting questions like, does a gunky world mean there's an infinite amount of stuff packed into every object? Does it mess with our ideas of continuity and identity?
It's making my brain hurt a little, but in a good way. But where does Mereology fit into all this? Does it take sides in the atomism versus gunk debate?
Mereology itself doesn't pick a side. It's just a framework for understanding parts and wholes, and it works with both atomic and gunky worlds.
So you could have a Mereology system that's built on atoms, or one that's built on gunk, and both would be logically sound.
Precisely. You can set up your mereological system with axioms that reflect either view. For example, an axiom stating that every single thing has a proper part would lead to a gunky system. But if you have an axiom saying that some things don't have any proper parts, that sets you up for an atomic system.
So again, we see how flexible Mereology is as a tool. It can work with different metaphysical ideas. But in the end, whether our world is atomic or gunky, that's a question for physics to answer, right?
It seems so. We need evidence to know for sure if there are those fundamental indivisible particles. But the fact that mereology can work with both views shows how connected it is to other areas of knowledge. It's not just some isolated logical game, it has implications for how we understand the physical world and what reality is all about.
Well, we've covered a lot of ground in this deep dive. We've unpacked the basic ideas of Mereology, wrestled with those tricky principles of antisymmetry and extensionality, explored the crazy world of composition principles, and even dipped our toes into the mind-bending concept of gunk.
We've certainly taken a whirlwind tour of some of the most fascinating and challenging questions of mereology.
I feel like my brain got a good workout. I bet our listener, who we know loves a good philosophical puzzle, is feeling the same way.
And as with any good philosophical exploration, we've probably created more questions than we've answered.
That's the best part, right? It's not about finding all the answers. It's about the journey, the excitement of exploring these complex ideas. And speaking of journeys, this is where our mereological adventure ends, at least for today.
But don't forget, this deep dive was just the beginning. There's a whole universe of mereological thought out there waiting to be discovered.
And if you're feeling inspired to keep exploring, we definitely recommend checking out the Stanford Encyclopedia of Philosophy's entry on mereology. It's packed with info and further reading on all the stuff we talked about and so much more.
Here's one last thought to chew on. If we accept that vagueness is a real thing in the world, not just in our language, does that undermine classical logic with its clear categories and sharp distinctions? Or is there a way to make those seemingly incompatible views work together?
Ooh, that's a good one to ponder. And with that, we'll say goodbye for now, fellow mereology fans. May your future explorations be full of wonder and amazing discoveries.